Controlling motion for videos generated by the Wan model has always been a massive headache for a lot of creators out there. But today, I'm bringing you a solution that is just leagues ahead of anything you've ever known. We're talking everything from simple movements to complex sequences, from a single character right up to a chaotic crowd. It's all completely under control. Hello everyone, I'm Sautai, welcome back to my channel. The videos on Wan Animate have been a huge topic of interest, and honestly, it's been one of the most viewed series on my channel lately. A massive thank you for all the enthusiastic support from everyone, and to return the favor, today I am absolutely hyped to share with you a new secret weapon for the task of video motion control. It's called SCAIL. The crazy thing is the community is already rating this solution as superior to even Wan Animate in a ton of tricky scenarios. With SCAIL, you can control literally every character action you want, from photorealistic humans to animation styles, from a solo shot to complex multi-person interactions. In this video, I'm going to walk you through a detailed step-by-step guide to building the SCAIL workflow in ComfyUI, and most importantly, how to optimize it so you get those spot-on results you're after. All right, enough talking. Smash that like button for me, subscribe if you haven't already, and let's get straight into it. Okay, before we dive deep and dissect the workflow, let me give a quick intro to SCAIL for those who might have missed it. This solution comes straight from the research team at Tsinghua University. If you're not in the loop, this is the #1 university in China and sits comfortably in the top 15 universities worldwide. So yeah, the credibility is off the charts. Just take a look at this demo. The real power of SCAIL lies in its ability to handle complex motions. We're talking about movements like bending over, spinning around, or twisting, the kind of stuff that usually makes other AI models completely fall apart. SCAIL handles it buttery smooth, but wait, there's more. You can apply this to animated characters, 2D styles, or even rough hand-drawn sketches. SCAIL understands the assignment and generates precise motion while keeping the exact style you're looking for. And here is the absolute money shot. SCAIL is specifically designed to solve the biggest nightmare in AI video: limb confusion. When two characters are standing close together, SCAIL clearly separates what belongs to character A and what belongs to character B. No more mutations or limbs merging into a messy blob. This is a total game changer compared to the Wan Animate solution I covered in previous videos. We all know Wan is great, but it often breaks down hard when faced with difficult movements or multi-person scenarios. SCAIL is exactly the missing piece we needed to fix that problem once and for all. Okay, sounds pretty awesome, right? Now, let me walk you through exactly how to build the SCAIL workflow in ComfyUI, and we'll put it to the test to see if the results actually live up to the author's demo. And of course, the first step is always prepping the environment to build this workflow. SCAIL has actually been integrated by Kijai into the Wan video wrapper. So you just need to install this custom node and you're ready to start building. On top of that, you'll also need to install 2 additional nodes that Kijai built specifically to support the SCAIL workflow: ComfyUI Kale Pose and ComfyUI Wan Animate preprocess. To install these custom nodes, just head into ComfyUI Manager, search for the node names, and click Install. Or, if you want to be a bit faster, go into your Custom Nodes folder in ComfyUI, open up a terminal, and type the git clone command with the links to their repos. Make sure to restart ComfyUI so it loads the nodes. Don't forget that step. And naturally, you're going to need to download the weight files for the models used in the workflow. First up are the basic models for the image to video workflow, like the LightX2V LoRa, ClipVision, UMT5, and VAE. You'll also need models to help extract skeleton information, specifically Vitos B and YOLO V10M. Finally, the SCAIL model itself, we're going to use the GGUF version to optimize VRAM usage, which is a lifesaver for those of you running on lower VRAM specs. I know hunting down links for every single one of these can be a huge waste of time, so I've compiled all the custom node links and necessary model links in the corresponding post over on my Patreon. You guys just need to click and download. All right, right in front of you is the complete SCAIL workflow that I've already set up. If any of you caught my recent videos on the bindweave solution, looking at this is going to feel incredibly familiar. The structure is almost identical, but if you're new here or missed that video, don't worry, I'm going to explain it again from A to Z right now to make sure everyone gets it. As with every video, let's talk about the core mindset of this workflow first. The heart of this system lies in these two nodes that Kijai integrated: SCAIL reference embeds and SCAIL pose embeds, as you can see right here on the screen. The job of this duo is to act as the translator. They take your control requests, process them, and package them up into a language that the Wan model can actually understand. Specifically, they need three main ingredients to work. Reference image, this is the image of the character or group of characters you want to animate. Next is clip embeds. This is still information from that reference image above, but it's been encoded through the clip vision model so the AI gets a deeper understanding of the details, colors, and lighting. And finally, pose images. This is your motion map, the skeleton video extracted from your source video. So in short, our goal today is simple. We create exactly these three ingredients and then we inject them into those two SCAIL nodes. The rest of it is standard procedure for anyone who's watched videos on my channel before. Now let's see how to create them in the main workflow. Okay, theory time is over. Let's get down to business. To keep things manageable, I've split this workflow into three distinct stages, exactly the same mindset I used with bindweave. First up, stage 1, input. This is where you give your orders to the AI. Start with load image. Drop your character image right here. Next, load video. This is the reference motion video you want your character to mimic. Down below are the technical specs. Video size represented by the length of the longest edge. The aspect ratio will be kept consistent with the reference video, along with the video duration. And finally, you can't forget the prompt used to describe the content of the video you want to generate. Your images and videos might come in all sorts of random sizes, so we need to add automatic resize nodes to bring them to the exact standard dimensions you input. After that, I assign them to variables named resized image and resized video to get them ready for stage 2. Moving on to stage 2, which I call the intermediate zone. Think of this as the kitchen on where we prep the ingredients from stage 1 so they're ready for cooking. First, I load the VAE and the SCAIL model. Here, I'm choosing the GGUF Q4 version. Heads up, for those of you rocking cards with 12 GB VRAM or less, definitely try the Q3 version or lower. Otherwise, you might see your system go up in smoke, figuratively speaking, with an out-of-memory error. And to speed up the render, I'm clamping the LightX2 LoRa right in here as well. Next, image processing. I use the Clip Vision Encode node to extract information from the resized image. I save the result into the variable clip embed. That's ingredient number 1. For the prompt, I do the same thing with the UMT5 model, save it to the variable T5 embed. Ingredient number 2 is done. And finally, creating the skeleton motion video. Here is the special thing about SCAIL compared to Wan Animate. Besides the motion video, I also feed the character image into the pose processing node. Why? So the AI can calculate the character's body proportions to match the movement. This prevents those awkward mismatches where a short character suddenly gets long, spindly legs. Oh, and I also reduce the input video size by half at this step to save some precious VRAM. Finally, stage 3, the main workflow. The job now is as easy as building Lego. We just need to take the variables and models saved in stage 2 and plug them into the corresponding ports of the two SCAIL nodes, along with the WAN video sampler node I introduced at the beginning. Super simple and logical, right? Everything is neatly organized. And just like that, you have completed the SCAIL workflow. Now for the moment of truth, click run and let's see how this beast performs. And here is the result. Wow. Yeah, this is actually incredible, guys. Just look at my werewolf character here. He pulls off a perfect 360-degree spin, matching the reference video literally millimeter by millimeter. Take a close look. There are absolutely zero artifacts, no motion blur, even during the fast movements. Everything is shockingly sharp and stable. This proves that our workflow is running like a well-oiled machine and that SCAIL has massive potential. Now join me as we run a few more tests so you can really understand the performance and the full range of what SCAIL can do. Okay, that previous example was a 3D character. Now let's switch gears and test out a more practical scenario that I know a lot of you are interested in: real human characters. Specifically, I'm going to use this photo of a girl right here. And here is the result. As you can see, just like last time, our girl executes that spinning motion perfectly, smooth and completely natural. But there's a really interesting detail here that I want you guys to pay attention to. My reference video is a full body shot, while the photo of the girl I uploaded is only a half body shot. And what did the AI give us back? A spot-on half body shot. Every detail of the limb stays right within the frame. The AI didn't try to hallucinate extra legs or mess up the proportions. This happened exactly because of the mechanism I explained in the workflow section. We fed the reference image in to adjust the skeleton right from the start. SCAIL basically understood, this guy only wants the upper body on-hom, and it executed that perfectly. Super smart. As for facial identity preservation, you can clearly see an almost absolute resemblance to the original photo. This is a massive leap forward compared to the original Wan Animate, which often morphed faces whenever a character turned around. Okay, now let's move on to an even more interesting experiment. I'm sure a lot of you are wondering, does this solution actually work when the camera is moving? Or is it stuck with just static shots? Well, here is your answer. Right here, I'm going to upload a video where the camera performs a dolly out, as you can see on the screen. This is a very cinematic angle, but it's also notoriously tough for AI to handle. And here's the result. Yeah, pretty awesome, right? SCAIL didn't just copy the body movement accurately, it actually copied the camera movement as well. The camera pulling back matches the original video perfectly. On top of that, take a close look at the details on this girl's bag. Even though this is a detail the SCAIL model had to generate itself, it maintained the texture incredibly well, with zero distortion even when the character was moving fast. This shows us that character consistency is preserved at a very high level with SCAIL. So we can confirm right now, SCAIL is absolutely not limited by camera movement. This opens the door for you guys to create professional, Hollywood-style shots right on your own computer. And finally, the final boss of the day, handling multiple characters. This is the ultimate stress test. I'm going to upload a photo of this couple along with a motion video of two dancers performing some pretty complex partner moves. Now let's hold our breath and see the result. Yes, absolutely fantastic. It's exactly what we saw in the author's demo. SCAIL generated a video of two characters dancing exactly like the reference video. And what is the standout feature here? The two characters move completely independently. There are absolutely no deformities, no scenes where one person's arm grows out of the other's back, or weird merging blobs like we saw with older solutions. This is a total game changer, a completely different level for SCAIL. Look at the identity preservation for both characters. Both the man and the woman keep their faces stable throughout the entire video. You guys know keeping the face consistent for just one character is already hard enough, but SCAIL is handling both at the same time and keeping it buttery smooth. Truly impressive. Through these tests, I can confidently say that SCAIL is an incredibly potent and powerful solution right now. It solves the biggest pain points for us AI video creators. Go install the workflow right now and experience it for yourself. I'm sure you're going to create a ton of interesting and surprising results. So that wraps up my guide on how to build the SCAIL workflow, a solution that is clearly superior to Wan Animate. I really hope you watch the full video to catch all the tips and tricks I shared along the way. If you found this video helpful, please smash that like button and share it around. It really helps get the word out and supports the channel. Thanks so much for watching. I'm Sotai, signing off. See you in the next one.